All right, pre-calc 11 pre-AP. Let's take a look at factoring and radicals lesson 6. So when we're doing this, we are finding ways to multiply and divide them. So we've done with addition, subtraction, other things. So we're going to collect stuff like that. So we've done this before in Math 10, right? So what we've done in Math 10 was we had stuff like 2 root 6, and we did this even as a little bit of a review this year, and times 5 root 3. All right, let's actually set this down. All right, and so we did that, so let's write this nicely. So I had 2 root 6 times 5 root 3, and then we would just multiply the like and the like, right? So 2 and 5, this is the same, that's a square root and that's a square root, so that's okay. So I'm going to change this into 10 root 18, but now I still have to simplify what's under the radical, so that is 9 and 2. 9 comes out as 3, and what I'm going to get is 30 root 2. And that's the product of the multiplication there, right? So everything comes out, that's good. We've been kind of doing that in previous lessons, makes sense to us. But now, let's see, can we do this with variables as well? Now I'm going to take negative 3 root 2x, and I'm going to take and multiply this all by, multiply this, oh, is that not working? Let's try this out. There we go. Multiply this by 4 root 3x. And again, these are all under the same square root for the parts that are, right? Square root and a square root. And our variable is going to be greater than or equal to 0. We don't want to worry about absolute value stuff. So the negative 3, negative 4 multiply, and I'll get negative 12. And then 2x and 3x multiply, and I'm going to get 6x squared. So I'm going to have 6x squared, all under a square root like that. And what I got to do now is the 6 has nothing I can take out, has no perfect square factors. So I can take out the x squared, and it can just come out as x since I declared x to be greater than or equal to 0. I don't need to worry about absolute values. So this is negative 12x root 6. And so that's my final answer here. But now we're going to do something like this. We're going to do something a bit more interesting. And that's where the interesting part comes in. We're going to do 2 root 3 minus 3 root 2, and that's one factor. And then we have another factor of 2 root 3 plus root 2. And we're going to see some stuff happen nicely here. Well, I have something that I have a binomial times a binomial, so we got our regular FOILing rules get to apply. So I have 2 root 3 times 2 root 3. That's the first. And then the next one I have is 2 root 3 times root 2, right? That's outer. And then let's go inner here, plus negative 3 root 2 times 2 root 3, and that's my inner. And then my last is plus negative 3 root 2 times root 2. Okay, and that's my last. And I'm just going to take care of these. I'm going to do these a bit quicker now. So that's 4 root 3 times root 3 is 3, so that's going to be 12, right? So I'm just going to take care of that. That's a bit quicker. I'm going to have 2 root 3 times 2, so this is going to be plus 2 root 6, okay? This is going to be negative 6 minus 6 root 6 for my inner, and then the last one is going to be root 2 times root 2 is 2, and then negative 3 times 2 is negative 6, so I'll get that. So ultimately, I'm going to collect like and like, what we learned to do in the last lesson, right? Collect like and like, and I'm going to get 6, and then 2 minus 6 is 4, minus 4 root 6, and that is my final answer here, right? So I can go ahead and FOIL everything and get the same answer, right? So, or get an answer that's more simplified, that's not multiplication anymore, right? And we're going to see why there's some advantages to that in a few moments here. But for now, like we have enough to do that. Well, let's try this with some extra wrinkles. Let's do this with something bigger than a binomial. Let's do a binomial trinomial. And let's make it a cube with a variable. So I get the cube root of x plus the cube root of y. Okay. And then I'm going to multiply this by the cube root of x squared. And some of you may already see where this is going. Minus the cube root of xy. And then plus the cube root of y squared. And we're going to see some nice things. I can already tell you a few things just by looking at it. When these two multiply, that's just going to be x. When these two multiply, that's just going to be x. And when, but we're going to get some xy squared, and we're going to get some x squared y. But we'll also get x squared y there, and we'll get x squared y here. So we're gonna get a few interesting things fall out. Looking at this again, x and the y, I'll still get 4. I'll probably go from 5 different terms to 4 different terms, but I might find some nice simplifications as we go along. Let's see what we can do. Oh, I see. I'm gonna do this my method, and then we'll try and see what the book suggests. So we can see what the book suggests. So this makes 6 multiplications here. And so I'm going to write 3 cube root of x, cube root x squared. We'll do that. And then the next one will be minus. I'm going to keep the negatives here in front because I know this will be negative and positive, make a negative. Cube root of x times cube root of xy, and then I'll get positive, so plus cube root xy squared. Let's keep them separate for now. Cube root x, cube root y squared, and then plus cube root y. So now I'm working on the y's all the way through. Cube root x squared plus, oh no, this will be minus. So I'm working on, at this point, I'm here. So I'm going to be cube root of y times cube root xy, and then plus cube root y, cube root y squared. And I have a feeling that we may get some stuff to fall out nicely. So this is just going to become, let's just make some stuff happen really nicely here. This will be cube root x cubed. This will be cube root x squared y. This will be cube root xy squared. This will be cube root of x squared y. And this will be the cube root of xy squared. And this will be the cube root of y cubed. Okay, let's make some nice simplifications here, or see if we can cancel any like terms. That and that go away. This and that go away, so the middle falls out. And this is just going to become x, and this is just going to become y. So at the end, I'm only going to get x plus y. That's it. So I only get x plus y at the end, so it works out very nicely for us. There's another method we could use here if we wanted to. We could go ahead and say, well, let's do this vertically. So you can do it vertically, just like how you would multiply 621 by 13. And you would do 3, 6, 18, 0, 1, 2, 6, and get 3, 7, 0, 8. So 8,073. You can also do get the same approach with polynomials. or radical expression. So this would be cube root of x squared minus cube root xy. And this would be plus cube root of y. And I'm going to multiply it all by cube root x plus cube root y. Okay. And really what I'm going to do is multiply each thing with each thing. And this should be a y squared on the end. So I'm going to get, this is going to be y. This is going to be minus 3. This is going to be minus cube root xy squared. And this will be the cube of x squared y. And now there's a blank spot here. So now we're just going to have to make sure that our columns still line up so that the result is in the right column. So this is going to end up right here because it's the same terms. So this is going to be plus cube root xy squared. And this will end up being cube root x squared y. And this will end up being x over there. We can add everything up over here. So we get y plus 0 is y. This and this makes 0 plus 0. This and this one. This one at the end. Am I missing a negative here? X squared. Oh yeah, this one should have a negative in front of it. Right, that should be a negative over there. So that's going to be plus 0, and that's just going to be x. And x plus y. So vertical multiplication also works, and you can kind of get some nice collections. There's some synergies with some stuff that we do later on in Pre-Calc 12 if you do it that way. I think I still prefer to just FOIL everything out. We'll do one more example, see some stuff as well, and we'll put the rest in the second video. So let's do one more. So let's do root x minus 2 all squared. All right, well, we can just do this by FOILing. Oh, this should be example 5. So this should be example 5. We'll do this by FOILing. So root x minus 2, root x minus 2. And let's just get some quick simplifications. Root x times root x is root x. And this is going to be minus 2 root x minus 2 root x, right? We're just FOILing along, plus 4, right? So how I got there is there, 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 there. And let's collect everything that we can, and we're just going to end up with x plus 4. We should have the radical in the middle. X minus 4, or root x plus 4. So it should look a little familiar to us that this is just kind of like our factoring rules, that we could do this also with rational exponents and square roots. Let's see, how much time is this? So far we're at 13 minutes. We can do, let's do last example for this. Let's multiply root 3 minus root 5. Okay. And let's do root 15 plus root 5. Now, the book, if you look at the book's example, they say do it by the rectangle method and look at the different areas that each one has. My beef with the area method for this question is that this, if you know that root 5 is bigger than root 3, right? Because when we apply a square root, we don't lose the value of the number like in order on the number line. So if you have root 3 minus root 5, you actually have a negative number, and it's not as intuitive as I would like for area. We could do it with root 3 plus root 5, and that would make more sense. But I just want to keep with the book example. And really, you're doing the same thing, right? Like FOILing is the go-to preferred way for a reason. It just makes things super simple for us. So I get root 45. I'm going to get root 15. I'm going to get minus root 75 here. And I'm going to get minus root 25 here. right? So I get a whole bunch of different areas. Let's simplify this. That becomes 3 root 5. This root 15 is all by itself. This is 5 root 3, right? That's 25, and this is 5. Is there anything that we can put together with it? Does not look like it. That's it. None of these actually live with each other, so that's that. Okay, I'll make look for part B coming up shortly.